Deep, detailed summary. In the simplest words possible, I will keep every sentence short. I will explain the main people, their ideas, what they did, and why it matters. At the end, you'll get a one-page cheat sheet you can read fast. What is geography? The word comes from two Greek words. Geo equals earth. Graphos equals writing or description. So geography equals writing about or describing the earth. The Greeks were the first to put ideas about the earth into a clear subject called geography. Why the Greeks are important? They collected what people knew. They made maps. They used measurement and reason. Their work became the base for later science and exploration. Key people and what each did. Simple and clear. Anaximander, early, about 6th century BC, one of the first to draw a map of the known world. He is called the first cartographer, mapmaker. His map was rough, but it was the first step. Thales, about 6th century BC, one of the first to try measuring things in nature. He started using numbers to understand the world. Hecataeus, about 6th to 5th century BC, wrote a book called Ges Periodos, meaning description of the earth. He listed places and peoples known then. Aristotle, 384 to 322 BC, gave strong, simple reasons that Earth is spherical, round. Evidence he used: ships disappear hull first on the horizon, shows curve. Earth makes a round shadow on the moon during lunar eclipses. Different stars are seen from different places. Hipparchus, about 2nd century BC, made the idea of dividing a circle into 360 degrees standard, built and improved tools like the astrolabe to measure stars. These tools helped find latitude and longitude, the system used to say exactly where on Earth. Eratosthenes, 276 to 194 BC, father of geography and geodesy, he gave the name geography. He measured the Earth's size using a simple, clever method. His method, very simple. 1. He noted at noon on a certain day the sun was straight above seeing, no shadow in a deep well. 2. At the same time in Alexandria, a stick did cast a shadow. He measured that shadow's angle, 7.2 degrees. 3. 7.2 degrees is 1/50th of a full circle, because 360 7.2 equals 50. 4. If the angle difference is 1/50th of a circle, then the two cities are 1/50th of the way around Earth apart. 5. He knew the distance between the two cities was about 5,000 stadia. 6. So he did 55,250,000 stadia for the full circle, Earth's circumference. What that means in kilometers. The length of a stadion is not exactly known today. Two common values used by historians give. If one stadion equals 157.5 meters, then Earth 39,375 kilometers, very close to modern 40,075 kilometers. If one stadion equals 185 meters, then Earth 46,250 kilometers, less accurate. His result, using the first stadion value, is only about 1.7% below the true equatorial circumference. Very good for simple tools. Ptolemy, about 2nd century AD, most famous classic mapmaker and geographer, wrote books that listed places by coordinates. His maps and ideas were used for many centuries. Later explorers in the 14th, 15th centuries used Ptolemy's work to start finding terra incognita, unknown lands. Strabo, 64 BC, AD 24, a geographer who thought Earth might be oblong, slightly stretched, shows that ancient thinkers tried many ideas. Science tested them later. Pliny the Elder, 23 to 79 AD, wrote Natural History, a big book about animals, plants, rocks, and places. It was an encyclopedia used for a long time. The big picture, how small steps made modern geography. 1. People watched the land, sea, and sky. 2. They described what they saw in books. 3. They drew maps to show where things were. 4. They measured angles and distances. Thales, Eratosthenes. 5. They made tools and numbers. Hipparchus, degrees, astrolabe. 6. They used reason and evidence. Aristotle. 7. They mapped. Perfect. Now that I've explained it line by line before, let me give you a great, deep, detailed summary, but still in simple, everyday English. This way you will see the whole picture clearly, like a story that connects everything. Deep, detailed summary of early geography and Indian contributions. So 1. Beginnings in Greece. Anaximander, 600 BC, Greece, drew the first map of the known world. That's why we call him the first cartographer, mapmaker. He took the step of turning land and seas into a drawing, which made travel and trade easier. Thales and Anaximander together are called the fathers of mathematical geography because they didn't just imagine the Earth. They used numbers, logic, and measurements to understand land and distances. This was the birth of scientific geography. Herodotus, 400 BC, Greece, called the father of history. He said, "You can't explain history without geography. Places shape events. You can't explain geography without history. Places are shaped by past events." He also tried to draw meridians, north-south lines on maps to give locations more accuracy. Meaning, the Greeks started geography as both drawing maps and measuring Earth mathematically. They also linked it with history. Number 2. The Dark Age in Europe, 300 to 1200 AD. During this time, Christian Europe is said to have gone through the Dark Age. Dark doesn't mean no life. It means there were fewer new ideas or discoveries. Learning slowed down. But at the same time, India, Arabia, and China made huge progress in astronomy, mathematics, and geography. Meaning, knowledge didn't die in the world, it only shifted away from Europe and grew strongly in Asia. Number 3. Indian contributions, ancient to medieval times. A. Rig Veda, 1500 to 1200 BC or earlier, the oldest known Indian text, mentions stars and describes 5 seasons, summer, monsoon, autumn, winter, spring, shows that Indians were observing the sky and the climate very early. B. Aryabhata, 476 AD, said Earth is round, when most people thought it was flat. Calculated Earth's circumference as 24,135 miles, today's modern figure is 24,901 miles. So close. Wrote Aryabhatiam. In Surya Siddhanta, the Hindi word Bugul, Bugul's earth, Goluk's round, was used for geography. Aryabhata was a genius. He proved Earth's shape, size, and even began the Indian word for geography. Varahamihira, 505 to 587 AD, famous after Aryabhata, explained solar and lunar eclipses scientifically. Wrote Panchasiddhantika, explained 5 different astronomical systems. He turned fear of eclipses into scientific explanation. Brahmagupta, 598 to 6665 AD, wrote Brahma Siddhanta and Khanda Kadyaka. His works were translated into Arabic during the reign of Caliph Harun al-Rashid, Baghdad. This shows how Indian knowledge spread to the Arab world and later, through Arabs, to Europe. E. Bhaskara Seketh, Bhaskaracharya, 1114 to 1185 AD, wrote Siddhanta Shiromani and Karanakutuhala. Said Earth is round and it pulls objects toward itself, an early idea of gravity. Famous math books, Lilavati, arithmetic, and Bijaganita, algebra. Bhaskara explained gravity 500 years before Newton, showing India's advanced scientific thought. Number 4, big picture. What does this mean? 1. Greeks, Thales, Anaximander, Herodotus, started geography as maps, math, and history together. 2. Europe's Dark Age, knowledge slowed there between 300 to 1200 AD. 3. India kept advancing. Rig Veda, Aryabhata, Varahamihira, Brahmagupta, and Bhaskara made discoveries in astronomy, geography, and math. 4. Knowledge travels. Indian texts were translated into Arabic, then spread to Europe, fueling later science. 5. Why it matters today. When we say geography, we are standing on the shoulders of both Greece and India. Maps, measurement, seasons, eclipses, Earth's shape, size, and even gravity were studied in India long before the West rediscovered them. Shows that civilizations share knowledge. No single country made science alone. It passed from India, Arabia, Europe. One-line memory chain, Anaximander at first map, plus Anaximander, math plus Earth. Herodotus, history, geography. Dark Age Europe equals fewer ideas. Rig Veda equals stars plus seasons. Aryabhata, Earth round plus circumference. Varahamihira equals eclipses. Brahmagupta, books, Arabic world. Bhaskara II plus advanced math. In short, geography began in Greece with maps and measurement, paused in Europe during the Dark Age, but in India it blossomed, with discoveries about Earth's shape, size, eclipses, and even gravity, centuries before Europe rediscovered them. Would you like me to now make this into a visual story, comic strip timeline, with little scenes for each person? Aryabhata showing Earth is round, Bhaskara dropping a stone, etc., so you can see and remember it forever? Perfect. Let's make a one-page, precise, systematic cheat sheet that covers Arab Europe contributions in geography astronomy. I'll design it like a quick revision sheet for exams. Geography and Astronomy Knowledge Flow Cheat Sheet. Indians, Bhaskara 1114 to 1185 AD, books, Siddhanta Shiromani Karanakutuhol, Earth is spherical, gravity, Earth attracts objects. Math books, Leelavati, arithmetic, Bijaganita, algebra, ancient geography, India, Jambu Dweep, eastern coast Mahendra Malay, prime meridian, then Ujjain. Other thinkers, Aryabhatta, Earth's circumference close to modern value, Varamihir, eclipses, Brahmagupta, Brahma Siddhanta, translated into Arabic, Bhaskaracharya, advanced gravity theory. That Arab world contributions, House of Wisdom, Baitul Hikmah, Baghdad, Knowledge Hub, translations, Al-Khwarizmi, 8113–883 AD, Sindh Hind, from Indian works, algorithm from his name, Caliph al-Mamun, 813 AD, Ptolemy's Almagest, translated Arabic Almagest, Al-Balaki, Kitab al-Ashkal, first climatic atlas, Al-Baruni, 973–1048 A, Kitab al-Hind, 1030, Geography and Culture of India, Al-Kanun al-Masudi, Astronomy, modelled on Ptolemy. Arab Age equals period of Al-Baruni, Arabs and monsoon, first seasonal study of monsoon winds. Yav Europe, Marco Polo, 13th century, travelled from Mediterranean, Pacific, spread Asian knowledge. Modern scientific link, Satyendra Nath Bose, India, boson theory, Peter Higgs, 1964, Higgs boson equals God particle. 1. India, original discoveries, gravity, astronomy, geography, math. 2. Arabs, preserved expanded knowledge, translations, climate, monsoons. 3. Europe, rediscovered through travellers, foundation for Renaissance science. 4. Knowledge moved India, Arab, Europe, modern science. This single page equals full map of contributions across civilizations. Do you want me to also create a visual timeline infographic, like a chart diagram, to show the flow of knowledge India, Arab, Europe, modern? That way you can remember it in seconds. Perfect. Let's now make deepest detailed summary of everything. Keep it very clear, systematic and step by step, so you can see the big picture of discoveries plus Renaissance geography development. Deep, detailed summary of great voyages and Renaissance discoveries. Numbers 1. Age of great discoveries, 15th to 18th century. Background. Before 1400s, Europeans traded with India, China, and the East only through land routes like the Silk Road. Problems. Land routes were long, dangerous, costly, and controlled by middlemen, like Arabs, Turks. So, Europeans wanted direct sea routes, started the age of exploration. Vasco da Gama, 1498, Portugal, first sailor to reach India by sea. Wrote, sailed around Cape of Good Hope, southern Africa, reached Calicut, India. Importance. Opened direct trade with India, spices, silk, and gems could be brought cheaply. Result, Portugal became very rich and powerful. Christopher Columbus, 1492, Genoa, Italy, planned to reach India by sailing westward across the Atlantic. Mistake. Instead of India, he reached America, Caribbean islands, called it the New World. Later, Amerigo Vespucci, another explorer, proved this was a new continent, named America after him. Ferdinand Magellan, 1520, Portugal. His expedition was the first to sail around the Earth, circumnavigation. This journey proved Earth is round, not flat. Though Magellan died on the way, his crew completed the voyage. Abel Tasman, Holland, 17th century, discovered Tasmania, island near Australia, Zealand. Importance, helped map the Pacific region. James Cook, 1772 to 1775, England, explored Antarctica for the first time. Also discovered Hawaiian Islands. His voyages improved maps of the Pacific. Rod Amundsen, 1911, Norway, first explorer to reach the South Pole, one of the greatest achievements in polar exploration. Number 2, Renaissance period discoveries, 14th to 17th century. Renaissance equals rebirth of learning in Europe after the Dark Ages, 300 to 1200 AD, when progress was slow. During this period, science, art, and geography flourished. Major discoveries and inventions, printing press, 1470, spread knowledge fast like the modern internet revolution. Copernicus, 1543, said the sun is the center of the solar system, not Earth. Heliocentric theory. Galileo, 1609, improved telescope, confirmed Copernicus' ideas. Kepler, 1600s, explained planets move in elliptical orbits, not perfect circles. Newton, 1600s, discovered gravity, explained Earth's shape as spheroid, bulging at equator, flat at poles. 3. Development of geography as a science. Earlier, geography was only about maps and travels. Then came Bernhardus Varenius, 17th century, Germany. Divided geography into systematic geography, general laws of Earth, climate, land, oceans, and regional geography, study of individual regions like India, Europe. This laid the foundation of modern geography. 4. Key impact of all these discoveries. 1. Trade became global. Spices, silk, gold, and new crops spread worldwide. 2. Maps of the world became more accurate. 3. Proved Earth is round. 4. Knowledge spread faster due to the printing press. 5. Astronomy and physics explained how Earth and universe work. 6. Geography became a scientific subject instead of just storytelling. In short, Vasco equals India by sea, Columbus equals America, New World, Magellan equals Earth is round, Tasman equals Tasmania and New Zealand, Cook, Antarctica plus Hawaii, Amundsen, South Pole, Copernicus, Galileo, Kepler, Newton equals changed astronomy and geography, Varenius equals father of modern geography. This is the deepest yet simplest summary. You now see the full journey, from finding sea routes, to discovering new continents, to scientific revolutions, to geography becoming a real science. Would you like me to now compress all of this into a visual one-page chart cheat sheet, like a timeline plus quick notes for ultra-fast revision? Perfect. Let's now make a deep, detailed summary of this passage. I'll give it in a clear, structured, step-by-step form so you can fully understand and remember. Deep, detailed summary, growth of modern geography. 1. Early foundation, Varenius, 17th century. Key idea, geography has two parts. 1. Systematic geography, studies general natural patterns like climate, rivers, mountains. 2. Regional geography, studies individual areas like India, Africa, Europe. Importance, first proper classification of geography as a science. Analogy, like a doctor studying the whole human body system, systematic, versus studying just one organ, regional. 2. Alexander von Humboldt, 1769–1859, Germany. Major book, Cosmos, combines science and geography to explain the universe. Contributions, proposed Panama Canal idea, connecting Atlantic and Pacific Oceans. Coined terms, climatology, study of climate, and permafrost, permanently frozen ground. Drew isotherms, lines on maps showing areas of equal temperature. Titles earned, Father of Climatology, Father of Modern Geography, Father of Vegetation Geography. Significance, brought science, maps and measurements into 3. Independent discipline, 19th century. Before, geography was part of history, astronomy. In 19th century, a separate subject in universities. Geography now studied not only land, but also relationship between humans and environment. 4. 20th century turn, human-environment relation. New focus, interaction between humans and their surroundings. 2 approaches developed. 1. Determinism, nature controls humans. 2. Possibilism, nature gives options, humans decide. 5. Friedrich Ratzel, 1844–1904, Germany. Book Anthropogeography. Ideas, father of human geography and political geography. Inspired by Darwin's evolution theory, survival of the fittest. Concept of Lebensraum, living space. Species need more area to grow. Compared state equals organism. Just like organisms grow, states must expand territory to survive. Impact, laid foundation for geopolitics. Political geography linked with land. Number 6. Vidal de la Blache, 1845–1918, France. Concept, possibilism. Nature offers opportunities, but human choices shape development. Role, considered the real founder of human geography. Example, a river can be used for drinking, irrigation, or transport. Humans decide the use. Impact, geography towards human decisions and culture. Nash 7. Sir Harford Mackinder, 1861–1947, Britain. Book, Democratic Ideals and Reality, 1919. Concept, Heartland Theory. Who controls Eastern Europe controls Heartland. Who controls Heartland controls World Island, Eurasia plus Africa. Who controls World Island controls the world. Importance, first geopolitical theory linking geography with world power. Impact, influenced world politics, especially in 20th century wars. 8. Carl Ortwin Sauer, 1889–1975, USA. Title, Father of Cultural Geography. Focus, human culture and landscapes, how traditions, farming and society shape geography. Example, terraced farming, city planning, deforestation, cultural impact on land. Nanav 9 Herbertson, 1865–1915, Britain. Contribution, first to classify the Earth into 15 natural regions, based on climate plus vegetation plus physical features. Significance, founder of natural geography studies. Example, desert, tropical rainforest, polar regions. Shasha, big picture, evolution of geography. 1. Varenius, split into systematic and regional. 2. Humboldt, made geography scientific, father of modern geography. 3. 19th century, geography becomes an independent subject. Ratzel, human and political geography, state equals organism, Lebensraum. 5. Vidal de la Blache, possibilism, human choices matter. 6. Mackinder, heartland theory, power politics. 7. Sauer, cultural geography. 8. Herbertson, natural regions of the world. In short, geography moved from describing land to scientific study to human-environment relations to political and cultural power. Do you want me to now compress this into a one-page exam cheat sheet, precise plus systematic, with tables and bullet points for super quick revision? Perfect. Now I'll give you a deep, detailed summary of the whole thing you asked about. Universe plus galaxies, Big Bang plus Andromeda. I'll make it systematic, easy to read, and super clear, almost like a one-page master note that you can use for revision anytime. Deep, detailed summary, universe and galaxies. Navana 1, universe, the everything definition. Universe equals all that exists, matter, energy, stars, galaxies, planets, and empty space. Cosmology equals science of the universe. Word origin, cosmos, universe. Logos, study science. Size, universe is 10 billion light-years, observable part. Light year, distance light travels in 1 year. Light equals fastest thing, travels around Earth 7 times in 1 second. Think of the universe as the biggest box that contains everything inside it. Number 2, origin of universe, Big Bang theory. Universe started 13.8 billion years ago as a tiny, hot, dense point. Proposed by Georges Lemaitre, Belgian priest scientist. Universe expanded like blowing a balloon and is still expanding. Steps after Big Bang. 1. Subatomic particles formed, protons, neutrons, electrons. 2. Atoms of hydrogen and helium formed, basic building blocks. 3. Gas clouds, dust appeared. 4. From these, stars and galaxies were born. Evidence. Expansion of galaxies, cosmic microwave background, CMB, of hydrogen and helium. Atoms. Building blocks of everything. Atom equals smallest unit of matter. Universe first made hydrogen and helium. Heavier elements like carbon, oxygen, iron came later inside stars. When massive stars exploded, supernova, these elements spread into space, helped stars, planets, and even life. Number 4. Galaxies. Star cities. Definition. A galaxy equals a huge system of billions of stars, with gas and dust bound together by gravity. Number, 100 billion galaxies in universe. Each galaxy has 100 billion stars, total equals 10 Gwen-Swift stars. Types of galaxies. Spiral, Milky Way. Elliptical, smooth, round, irregular, odd-shaped. Dwarf, smallest ones. Analogy. If the universe is a country, a galaxy is a city. Stars are the houses inside that city. Number 5, Milky Way. Our home galaxy. Definition. Milky Way equals the galaxy where Earth and solar system live. Shape, spiral galaxy, like a whirlpool. Age, formed 5 billion years after Big Bang. Discovery seen with telescope by Galileo Galilei. Special fact, that faint milky band across the night sky, the Milky Way itself. Number 6, other galaxies. Andromeda Galaxy, nearest large galaxy to Milky Way. Dwarf galaxies, small galaxies, latest known discoveries. Number 7, 2 broad parts of universe. 1. Atmosphere, layer of gases around planets like Earth. 2. Space, region beyond atmosphere, planets, stars, galaxies, black holes. Number 8. Extra concepts, dark matter, invisible matter, does not give off light but has gravity, holds galaxies together. Dark energy, unknown force causing the universe to expand faster. These together make up most of the universe's content, 95%. One-page cheat sheet, universe equals everything, matter plus energy, galaxies, space. Cosmology equals science of the universe. Size equals billions of light years wide. Origins, Big Bang, 13.8 billion years ago, Georges Lemaitre. After birth, atoms, gas clouds, stars, galaxies. Atoms equals hydrogen, helium, later heavy elements inside stars. Galaxy equals star city, billions of stars, dust, gas. Total equal 100 billion galaxies, 100 billion stars each. Milky Way equals our spiral home galaxy. Galileo saw it first. Andromeda, nearest big galaxy. Dwarf galaxies equals latest discovered. Universe parts, atmosphere plus space. Dark matter equals invisible glue. Dark energy equals expansion driver. This is the deep plus detailed but super simple summary. Now tell me, do you want me to turn this into a visual timeline diagram, Big Bang, atoms, stars, galaxies, Milky Way, or into comic strip-style notes so you can picture it easily? Perfect. Let's now make a grilled summary of the Big Bang theory and other origin theories. I'll keep it clear, simple and systematic, but also deep enough so that you don't just memorize facts, you truly understand them. Deep, detailed summary of the Big Bang and theories of universe origin. 1. Starting point. The primeval atom. At the very beginning, all the matter and energy of the universe were packed into a tiny, super-hot and super-dense point. This was called the primeval atom. Imagine the whole universe, stars, planets, galaxies, space, and even time, squashed into a dot smaller than a pinhead. Number 2. The Big Bang, 13.8 billion years ago. Not a bomb explosion. Instead, space itself expanded from that tiny state. This expansion started around 13.8 billion years ago. As the universe expanded, it cooled down. Cooling allowed particles, atoms, stars, galaxies, planets to form. The universe has been expanding ever since. Analogy: blow air into a balloon with dots drawn it. As the balloon expands, the dots move away from each other. That's how galaxies move apart. Now 3. Evidence for the Big Bang. Why do scientists believe this? 3 strong pieces of proof. 1. Galaxies are moving away, Hubble's law. Light from distant galaxies is shifted to the redshift. This shows they are moving away from us. Universe is expanding. 2. Cosmic microwave background, CMB. A faint glow over radiation found everywhere. This is the baby photo of the universe, released about 380,000 years after the Big Bang. Proves the universe was once very hot and dense. 3. Of light elements. The universe has mostly hydrogen and helium in the exact amounts predicted by Big Bang physics. This shows those elements were formed in the early hot universe. Number 4. Inflationary theory. Alan Guth, 1981. After the Big Bang, the universe had a short phase called inflation. Inflation equals super-fast expansion, even faster than light, in less than a second. Why needed? It solves puzzles. Horizon problem, why the universe looks the same temperature everywhere. Flatness problem, why the universe looks so geometrically flat. Monopole problem, why we don't see strange predicted particles. Analogy, a tiny balloon blown up super fast looks flat and smooth. Number 5. Other theories of universe origin. Not everyone agreed with the Big Bang at first. Other ideas were suggested. 1. Steady-state theory, gold-bonded. Universe has no beginning and no end. New matter is created continuously as galaxies move apart. Lost popularity because it cannot explain the CMB and changing universe structure. 2. Pulsating universe theory, Sandage. Universe expands, then contracts, then expands again. A cycle of Big Bang and Big Crunch. Modern evidence of accelerated expansion makes this less likely. 3. Big Bang with inflation. Most accepted today. Universe began with Big Bang, followed by inflation, supported by strong evidence. Number 6. Universe today. The universe is still expanding, and in fact it's expanding faster now. This is due to dark energy, a mysterious force pushing the universe apart. Dark matter is another invisible ingredient. Acts like hidden gravity that holds galaxies together. Current universe composition: 5% normal matter, stars, planets, US, 27% dark matter, 68% dark energy. Number 7. Key takeaways. Primeval atom. All matter squeezed into one point. Big Bang 13.8 billion years ago. Space expanded. Expansion continues. Galaxies still moving apart. Evidence redshift, CMB, light elements. Inflation explains smoothness and structure. Other theories exist, but Big Bang with inflation is strongest. Universe today, mostly dark energy plus dark matter, with normal matter only a tiny fraction. Number 8. Super simple story version. The universe began as a tiny, hot, dense dot. And then about 13.8 billion years ago, it rapidly expanded. This was the Big Bang. Space stretched, matter formed, then atoms, stars, galaxies, and planets appeared. We know this because galaxies are moving apart. We see leftover radiation CMB, and the universe has the right mix of hydrogen and helium. Other theories like steady state and pulsating were suggested, but the Big Bang with inflation best matches evidence. Today, the universe is still expanding, even faster now, driven by mysterious dark energy. This is the deep, detailed, yet simple summary. Would you like me to now make this into a one-page cheat sheet diagram with visuals, balloon, raisins, timeline, CMB glow, etc., so you can see everything at once and revise super quickly? Perfect. Condense everything into a one-page cheat sheet, clean, schematic, precise, but still simple and clear. Nash Stars and Solar System Ultimate Cheat Sheet. Stars formation, nebula, huge clouds of gas dust. Gravity pulls gas dust together, clump grows, center heats up. When hot enough, 10 million fusion begins, He. Fusion releases energy equals light plus heat, a star is born. Properties, made of hot gases, mainly hydrogen and helium, emit their own light and heat, unlike planets, very large and hot. Sun can fit 1 million Earths inside. Colors show temperature, blue equals hottest, yellow, white equals medium, red equals coolest. Life of stars, short. Small stars, red giant, planetary nebula, white dwarf. Big stars, supernova, neutron star, black hole. Distances, measured in light years, distance light travels in 1 year. Nearest star to Sun, Proxima Centauri, 4.25 light away. The Solar System main members: Sun, a star, center of the system, source of light and heat. Planets, in order: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Moons, natural satellites revolving around planets. Small bodies, asteroids, rocky, many an asteroid belt between Mars and Jupiter. Comets, icy bodies, form tails near Sun. Meteoroids, small rocks in space. Meteor burns in atmosphere, shooting star. Meteorite equals reaches Earth's surface. Structure, inner rocky planets, Mercury, Venus, Earth, Mars. Outer giants, Jupiter and Saturn. Gas giants, Uranus and Neptune, ice giants. Other regions, Kuiper belt, icy objects, e.g. Pluto. Oort cloud, distant shell of icy bodies, source of long-period comets. Orbits and motion, orbit is path of planets around Sun. Shape elliptical, oval, not perfect circle. Gravity of the Sun equal invisible pull keeps all objects bound. Without gravity, planets would fly off into space. Time definitions. Day equals 1 rotation of planet on its axis. Year equals 1 revolution of planet around Sun. Seasons caused by tilt of Earth's axis. Tides are caused mainly by Moon's gravity and partly Sun's. Attached to eclipses. Solar eclipse, Moon blocks Sun's light seen from Earth. Lunar eclipse, Earth blocks Sun's light, casting shadow on Moon. Hannah memory boosters. Planet order, my very educated mother just served us noodles. Star birth, cloud, squeeze, fusion, star. Asteroids versus comets, rock versus ice. In one line, stars are giant balls of burning gas formed by gravity and fusion. The solar system is the Sun plus planets, moons, small bodies, all held by the Sun's gravity in elliptical orbits. Would you like me to turn this into a visual infographic style page with simple icons and diagrams like nebula, star, Sun in center, planets around, so you can use it as a study poster?
Absolutely. Here's a world-class one-page cheat sheet for the Sun, extremely concise, exam-friendly, including all important points, numbers, and keywords, so you can quickly revise. The Sun Cheat Sheet. 1. Basic facts. Star type. Star at center of solar system. Nearest star to Earth, ultimate source of energy for life on Earth. 2. Size and structure. Size, 1,300,000 times Earth. Diameter, 100 kilometers Earth. Composition, hydrogen, H, 71%, helium, He, 26.5%, other elements, 2.5%, O, C, Phi, etc. 3. Energy and nuclear fusion. Core process, hydrogen, helium, nuclear fusion. Releases, tremendous heat and light. Surface temperature, 5778 Ks, 5,500 5Zs, 9,940 degree Fahrenheit. 4. Solar activity. Solar flares. Storms of hot atoms escaping Sun travel to space. Effects on Earth. Collide with atmosphere. Auroras, North Pole. Aurora Borealis, South Pole. Aurora Australis Tower 5. Key roles. Provides light, heat, energy for life. Controls day-night cycles. Influences seasons, weather, climate. Source of auroras and space weather. 6. Quick visual comparison. Feature, Earth, Sun. Diameter, 12,742 kilometers, 1,400,000 kilometers. Size 1,300,000 times bigger. Temperature, 15 degrees Celsius, 555 degrees surface. Composition, NaH 71%, He 26.5%, others 2.5%. Function, life exists, provides energy for life. Exam keywords, sun, star, solar system, nearest star, center, hydrogen, helium, nuclear fusion, heat, light, solar flares, aurora borealis, aurora australis, diameter 14,577,78K, 1,300,000 text Earth. If you want, I can make an even more compact, super memory-friendly one-pager with all numbers, facts, and arrows, so you can revise in 30 seconds before exams. Do you want me to make that version too? Here's a world-class one-page cheat sheet for Aditya L1, made super crisp with bullets, keywords, and dates for quick exam revision. Nothing important is missed. Aditya L1 cheat sheet, India's sun mission name and meaning. Aditya, sun, Sanskrit. L1, Lagrange point 1, Sun-Earth gravity balance point. Purpose, study the sun comprehensively. Focus, outer atmosphere, corona. First Indian space-based mission for sun study. Launch details. Date, 2nd of September 2023, rocket, PSLV C-57, Agency ISRO, Indian Space Research Organization. Instruments, payloads, total 7 payloads, all made in India, 5 by ISRO, 2 by Indian universities, with ISRO collaboration. Functions, measure solar light, particles, magnetic fields, corona. Orbit position, initial Earthbound orbit for 16 days. Final, L1 point, 21.5 million kilometers from Earth. Always facing sun, 1% of Earth-Sun distance. L1 equals gravitational equilibrium. Satellite remains stable. Safety, mission facts. Will not land on sun. Will not approach sun closer than L1. Observes the sun remotely and safely. Significance keywords. First Indian solar mission. Indigenous payloads. Studies solar corona, helps understand space weather, solar storms. Sun-Earth system, gravity balance, Lagrange point. Source. ISRO, Department of Space. If you want, I can also make a super condensed exam memory map